someone raise your hand and tell me what is different between your drawing of your rock and your drawing of your mineral? Give me one difference. Yes.
The mineral can have a perimeter and a circle.
Okay. Something else. Yes.
The rock, it has kind of roughier edges while the mineral is straight cut, like
Okay. Does anyone else have any more differences between your two drawings? Yes.
The mineral I drew has a triangular pattern.
Okay. What about you?
Well, one difference is that one is a rock and one is a mineral.
Okay, that is a difference. So, here's the deal. I am not going to tell you whether your rock and your mineral drawings are right or wrong, or whether your differences are correct or incorrect. After today, you're going to go home this weekend and you're going to look back at your drawings and you are going to decide, do my drawings look correct? Do I have the right properties? And are my differences correct? Okay? So that's your job this weekend after our lesson, okay? So, today we're going to discuss how to tell the difference between rocks and minerals. Probably noticed that from everything that is sitting on your desk.
Click on the bright, the icon right next to it. Yeah, right there. And once you come off of it, it'll come off.
Oh, thank you. Okay, so today we are talking about rocks and minerals. And you've done a lot of this so far with Miss Turner, so it should kind of be a review. So throughout the lesson, I'm going to ask you a question and I need you to talk back with me, okay? But you're going to listen, you're going to raise your hand to respond. If you have a question about a specific rock or a mineral, I want you to write it down for me and I'll take it at the end. And if we have time, we can talk about it. And if not, I'll write you an answer and get back to you on Monday, okay? Okay. So, rocks and minerals, how do you tell the difference? So, identifying rocks and minerals. So minerals, someone tell me, what does it mean that a mineral is formed naturally? What does it mean to form naturally? Yes.
When it says form naturally, it is always not naturally
Okay. Anybody else have an idea? Okay. Yes. Okay. Yes. So minerals are formed throughout different processes that the earth carries out, okay? So they can be formed in many different ways. And the type of mineral that forms depends on the elements that are present where the mineral forms. Does that make sense? So if I have certain elements over here, they're going to form a certain mineral. But if I have different elements, then they're going to form a different mineral, okay? So I know that you talked a little bit about elements, and so hopefully we can get our minds kind of going with that in just a second. So it matters what type of elements are present. It also matters the temperature and the pressure. If you have three elements together that are going to form to make a mineral, and it's really, really hot there, or it's not as hot, that can make a different mineral depending on the bonds that form between atoms. So, you know what an element is. Can someone tell me what an element is? Yes.
element is the thing that can be found in nature that is used for human resources.
Okay, what else? What's an element? Yeah.
Elements come from the periodic table.
Yes, very good. And so elements make up minerals. Well, atoms make up elements, okay? So atoms are tiny, tiny particles that we can't see with our eyeball, okay? And so they are the smallest unit of matter that makes up an element, okay? So, and when elements and minerals form, the atoms bond together, okay? So we have atoms coming together. And that bonding is going to help us create our mineral, okay? So, we have the type of minerals present are going to determine what mineral forms. The temperature is going to determine what mineral can form whenever the pressure and the temperature and the minerals are different, okay? So, and then minerals can form when? Someone tell me. When can a mineral form in nature? What creates that? Yes. Okay, pressure, what else? Like what type of, when something happens in the environment, tell me what can happen in the environment to cause a mineral to be created. Yes.
Tornadoes.
Okay. Give me another idea. Yes.
Water evaporation.
Good. Water evaporation. What else? Okay. Maybe that could create one. Rain. Okay. Any other ideas? Yes. Okay, well that's actually going to help form rocks, but we'll get to that in a few minutes. Okay, guys, listen to me. So, there are several different ways that minerals form in nature, okay? So I have them listed. So why don't y'all write these in your journal for me, okay? So, minerals can form in nature whenever water evaporates, okay? So if elements are present in water and the water evaporates, that leaves space for those elements to bond together and form a mineral. Give me a second. Okay? New minerals can also form whenever you have one mineral that melts. If there's a large heat source that causes it to melt, so that means that the bonds are going to break within the mineral, okay? So they're going to break, and then when it cools, the bonds can reform, but they might form in a different manner, and it might make another mineral. So maybe you started with this mineral, maybe it was, for instance, this purple mineral, and it melted. And then when the bonds broke and then it cooled and they reformed, it created a completely different mineral because of the way that the bonds interacted with each other. And then again, whenever heat and pressure are present on minerals, that can cause them to change from one mineral to another, depending on what happens between the bonds of those elements and atoms. And then finally, there are actually some living organisms that produce minerals, which is not very common, but there are some. And there are some ocean animals that produce shells to protect themselves. Does anyone have an idea what that might be? Yes.
Oyster.
Yes. An oyster is an example, okay? So the oysters produce minerals to form a shell to protect themselves. Give me a thumbs up if you have this slide down. Okay, almost. I'll give you a second. So the big point from this slide is that minerals form naturally, okay? They are made in nature through natural processes. Right now. Okay. So now, our next point, our next property of mineral is that all minerals are solids, okay? So that means that if you have a liquid, it is not a mineral, okay? It is not classified as a mineral. So give me a thumbs up if you think that you could classify water as a mineral. Okay? Give me a thumbs down if you think that water is not a mineral. Yeah, okay. So water is not a mineral because it is a liquid, okay? Minerals have to be solid. So that means that they have a definite form, okay? So like this object right here, I'm not going to tell you what it is yet because we'll get to rocks versus minerals in a second. But this has a definite form. It's not going anywhere. I can hold it in my hand, okay? So it has a definite form and a definite volume. See, is the shape changing when it's sitting in my hand? No. Is the volume changing? No. Okay, so, solid, okay? Well, here's a really cool thing about water. So water you the next time. Maybe you'll be able to see the crystal structures if you get a magnifying glass, okay? So a piece of, listen to me, a piece of ice is going to share the same characteristics that our minerals are going to that we're talking about. And I think that's awesome because you use ice probably every day. So there's a mineral that you use every day in your life, okay? So, number 3. Minerals have a definite chemical makeup. Can someone tell me what that means? A definite chemical makeup. Yes.
When you say minerals have a definite chemical makeup, you mean that minerals are made up of type of atoms, and whichever type of atoms that conjoin, they make one mineral.
Very good. So one type of mineral is always going to be made up of the same things, okay? So let's talk about ice. What is ice made up of? Raise your hand.
Water.
Okay, water. But what elements are in water? Yes.
One hydrogen atom and 2 oxygen.
Okay? Vice versa, 2 hydrogen and 1 oxygen. Great job there. So every single ice cube that you have in proportion is going to have 2 hydrogen atoms for 1 oxygen atom. Okay? So this ice cube is going to have 2 hydrogen atoms and 1 oxygen atom all bonded together in a formation. Well, guess what? This ice cube over here, how many hydrogen atoms is it going to have? 2. Okay? And well, to make in the 1 atom. So you're not going to have, in this one, if you have 2 hydrogens for every 1 oxygen, and this one you're not going to have 3 hydrogens for every 1 oxygen. You're going to have 2 hydrogens for every 1 oxygen, okay? So that means that every single mineral has the same exact makeup. Does that make sense? Do I need to explain again? Okay. So they are always composed of the same elements. They also typically, because they're composed of the same elements, they're going to kind of look the same throughout, okay? So, whereas, I'll go ahead and give a seat. Does this one look the same all the way through? Yeah. See, this one, this is a rock. I'll go ahead and give you this one. This is a rock, and it does not look the same throughout. What colors do you see in there? We have lots of colors in here, okay? We have some pieces are shiny, some pieces are dull, okay? So this is a rock. However, this, what do you think about this? Do you see anything different in there? Does it look the same throughout? Yeah. Okay, so this, typically minerals are going to look the same throughout, okay? For instance, let's look up here at this picture. So I don't see a whole lot of particles forming together. I don't see pieces of minerals all spread throughout. It looks pretty uniform, doesn't it? Yeah. So that is one way. When you're looking at your minerals versus rocks, if you're struggling, man, I just don't know whether this is a rock or a mineral. Typically, your mineral is going to look more uniform, more the same, and your rock is going to kind of look scattered, okay? And number 4 of minerals. All minerals have crystal structures, and I know that y'all have been talking about this because I was here. So raise your hand and tell me, what does that mean, that a mineral has crystal structures? Anybody back there have an idea? Okay. Listen.
If a mineral has crystal structures, then that means it's fine grained, because if it's fine grained, it means it cools slowly and it gives crystals. It gives crystals a chance to grow.
Okay. Good job. What else? How does a crystal, like, what is a crystal? What does it mean whenever I say this mineral has crystal structures? Yes. Okay. So a lot of times you can see the crystal structures with your naked eye. Sometimes you might have to use a magnifying glass. Do you have an idea?
Also, there are many crystals inside to make up.
hit it with a hammer, it's gonna be kind of rugged, okay? Like, for instance, this one, it's kind of rugged because that means that all of the bonds between the particles and between the elements are the same strength, okay? However, with this one has cleavage, okay? So that means that whenever it was hit with something, it broke along flat surfaces because the bonds in that area where it broke were weaker, okay? So it was able to split on an even surface. Does that make sense? Give me a thumbs up if you got that. I know y'all talked a lot about that. Good deal. So now we talked about the properties of minerals. Let's go into the properties of rocks, okay? So be sure that you're writing this down so that you'll be able to look at our rocks and minerals later and determine what you have. Okay, so again, like minerals, rocks are going to be solid. Someone remind me what that means. What does it mean to be a solid? Yes.
That it's not gonna be water,
Right. Good. So it's not a liquid and it's not a gas. It has to be a solid. I can hold it in my hand or it can sit on the floor, okay? And if I put it somewhere, it is not going to move. It's not going to spread out like a liquid or a gas would. And rocks are also formed naturally. Someone tell me how a rock could be formed. What did you say earlier? What did you say? Yes. Tell me what you were talking about. Okay. So for instance, erosion. So whenever water or wind causes particles to break off of a rock or a mineral and they are deposited somewhere else, they can be deposited in layers and that can end up forming a rock, okay? What else can form rocks? Yes.
a volcano.
A volcano, very good. What else? Yes. Okay, good. Naga, what else? Yes.
When rocks are, when pressure is applied to multiple rocks creating a
Very good. So if pressure or heat are applied to multiple rocks, they can come together and form a new rock, okay? So let's go on to figure out what the difference is between rocks and minerals because these two characteristics are the same, right? They're solids and they're formed naturally. Let's move on. Okay, so here's our big difference between rocks and minerals. I know y'all know this, so someone raise your hand and tell me what's our huge difference. Yes. Okay. Yes. Good. Can you tell me why rocks don't look the same throughout? Do you remember why? Okay. Okay. Good. Yes. Very good. That was what I was looking for. Great job. Okay. So rocks are typically made up of one or more minerals. Okay. So let's look up at this picture right here. I see that I have lots of little particles, and then I have what looks like a kind of a solid mineral right there. So we can definitely see the mineral here, and then we see all of these other tiny minerals. Okay. And so this actually found a rock like this. I think it's on one of your tables. But so this part right here feels smooth, and then the rest of it feels rugged. Okay. So that shows us that this rock is made up of lots of different minerals. Okay. So when one or more minerals come together, they can form a rock. Okay? So the big difference when you look at a rock is that typically you're going to see lots of different minerals, okay? Maybe you might have to use your magnifying glass, but you should be able to see different types of minerals throughout that rock, okay? That's typically what you're going to see. Okay, so another thing about rocks that might help you distinguish between them is that they don't always form in orderly structures. Like we talked about how the crystals are always going to form the same in a certain mineral. Well, with rocks, for instance, with a sedimentary rock, when erosion and wind happen and they settle, they're going to settle in whatever order they came down, right? And then when they're compacted into a rock, it could look like that, or it could look different. These particles could be more spread out. See, there's not right in here. There's not really any pattern of where the particles are laid out. They're just there, okay? So they don't necessarily have an orderly structure. Does that make sense? Yes.
Since sedimentary rock is a little rock
typically sedimentary rocks are foliated, the ones that I've seen, at least. But some of them can look like that, and they're not necessarily foliated. Okay. So another thing about sedimentary rocks, you brought up a good point. They can look like they have layers, right? Because they're compacted. Well, they're still different from minerals because they are made up of different minerals, okay? So remember we talked about how the mineral is the same throughout. Well, even with your sedimentary rocks, if it looks uniform, you're still probably going to be able to see the different minerals throughout it. Give me a thumbs up if you have an understanding of that. Okay, good deal. Now, we are going to work together to determine whether I have rocks or minerals. Okay, so everyone look up here for me. I have object number 1 and I have object number 2. We are going to work together to decide whether this is a rock or a mineral and whether this is a rock or a mineral, okay? To do this, listen, to do this I'm going to need some help. Not yet. You don't know what you're volunteering for? Listen. Oh, wait. Okay, but one thing that I need you to do is I need you to remain quiet, okay? Because your classmates are going to come up here and you're going to tell me, if you come up here, you're going to tell me one characteristic. You can pick either object that you want. So you would pick it and you would say, this is a liquid. Obviously this is not a liquid. But if I was looking at something, I would say, this is one characteristic. You are only telling me one characteristic. How many? One. Okay. So don't say, okay, this is a liquid and it's a gas and so and I think it's a rock. No. You are going to tell me, listen, you are going to tell me one characteristic. And then, here's the rest of the class's instructions. After that characteristic, I will say, class, is this a rock? Is this a characteristic of a rock or a mineral? If it's a characteristic of a rock, you're going to hold up one finger. If it's a characteristic of a rock. If it's a characteristic of a mineral, you're going to hold up 2 fingers. If it's a characteristic of both rocks and minerals, you're going to hold up 3 fingers. Okay? So someone raise your hand and tell me, what does our 1 symbolize? It's a characteristic of what? Yes. A rock. 2. 3. Both. Very good. Okay. So, who would like to come tell me a characteristic? Let's see. What about someone who I have not heard from today? is a rock? Okay, I'll wait until everyone's listening. Okay, good, thumbs down. Thumbs up if you think this is a rock. Number 2, is this a rock? Thumbs up. Thumbs up if you think this is a mineral. Good job. Okay, so here's what's going to happen now. I have helped you decide with these, but what you're going to do is in your table group, I need all eyes on me. Okay, all eyes on me. So you have 4 rocks and minerals on your table. Don't touch them yet. Here's your most important instruction. They are sitting in a petri dish or either in a cup. You may take them out of the petri dish or the cup. However, if I take this object out of this cup, it has to go back in this cup, okay? Does that make sense? So if you take this out of here, you cannot put it in number 2. This cup says number 1. This has to stay in number 1. Okay? Hold your questions until the end. 1 second. 5, 4, 3, 2, 1. I'm not done with instructions yet. You should not be touching anything. Okay, so your rocks and minerals are numbered. You are going to work with your table group. In a second, I'm going to put up a table. You are going to copy this chart into your journal. Okay, look at me. This chart is going to go in your journal. So you have the number. So number 1, I'm going to be looking at rock number 1. And I'm going to write whether my group thinks it is a mineral or a rock. But I don't stop there, because remember, we have to prove everything in science, okay? So then over here, you're going to write your evidence for me. And you're not just going to put, because my group said so. You are going to list characteristics that we talked about today and that you have learned with Ms. Turner, okay? So you're going to list characteristics. You are going to do this for each rock. When you finish your table, if we have time, you're going to switch with the other table group, okay? So, for instance, right now, this table has rocks and minerals 1 through 4. So they are going to mark on boxes 1 through 4 on the chart, okay? But this table right here has 5 through 8. So instead of starting with 1, they're going to start with number 5, okay? Give me a thumbs up if